how ASML makes chips faster with its new $400 million High-NA machine. In the relentless race to produce ever smaller and faster computer chips, ASML, the Dutch powerhouse of semiconductor manufacturing equipment, has once again raised the bar with its revolutionary $400 million high numerical aperture High-NA EUV lithography machine. This innovative tool represents a significant advancement in chip-making technology that has the potential to reshape Moore's law and prolong the semiconductor industry's existence well into the Angstrom period. Chipmakers are now able to produce transistors at previously thought to be impossible scales because to the High-NA EUV system's unparalleled precision, speed, and patterning capabilities. The machine's exorbitant price tag is a reflection of both its technological complexity and its vital significance to firms such as Intel, TSMC, Samsung, and Micron, who are all vying for market leadership in advanced DRAM and sub-2 nanometers logic. The foundation of future chip manufacturing, ASML's High-NA platform allows processors that power everything from smartphones to AI data centers to run faster, more effectively, and with less electricity. It is not simply another small advance. This video examines the 7 main ways that this innovative machine will permanently change the semiconductor manufacturing industry. Let's watch. 1. Lithography precision is redefined by high numerical aperture. By greatly expanding its numerical aperture from 0.33 to 0.55, ASML's innovative high numerical aperture, High-NA EUV machine represents a significant breakthrough in semiconductor fabrication. With this improvement, features as small as 8 nanometers may be created in a single exposure by using the technology to project ultra-fine patterns onto silicon wafers with unparalleled accuracy. In the past, creating such small structures necessitated several patterning stages, which increased manufacturing costs, complicated the process, and increased the possibility of errors. The High-NA technology reduces mistakes and boosts chip production efficiency by streamlining the entire lithography process through single-pass patterning. Transistor density directly increases as a result, opening the door for faster, smaller, and more energy-efficient CPUs of the future. This technical advancement guarantees that ASML's High-NA machines will continue to be crucial to surpassing the physical constraints that have long hampered conventional lithography techniques as the global semiconductor industry rushes towards the 2 nanometers process node and investigates even smaller dimensions. 2. Increased production speed due to faster wafer throughput. In addition to redefining accuracy, ASML's groundbreaking High-NA machine establishes new standards for silicon wafer processing speed. Since attaining finer detail frequently slows down the manufacturing process, compromising throughput has historically been a major concern when improving resolution in chip fabrication. But ASML has cleverly fixed this by adding ultra-fast wafer and reticle stages to the High-NA system. These parts accelerate at previously unheard-of speeds, making up for the machine's smaller exposure field area due to its sophisticated optics. Consequently, in its current configuration, the High-NA tool can process an outstanding 185 wafers per hour. Engineering roadmaps indicate that this capacity will increase to 220 wafers per hour in the upcoming years. Because of this remarkable throughput, semiconductor fabrication factories, or fabs, may maintain or even grow their chip output without compromising efficiency or performance. Together with its accuracy, the machine's speed ensures that producers can keep up with the growing demand for chips that are faster, more potent, and use less energy while preserving operational profitability and productivity in a market that is becoming more and more competitive. 3. Increased reliability lowers expenses and downtime. EUV lithography tools have historically struggled with reliability, but ASML's High-NA technology significantly improves this crucial area. ASML developed its new platform with enhanced subsystems, more resilient handling mechanics, and better light source stability after studying the operating data of earlier EUV generations. The efficiency of high-volume semiconductor fabs depends on these developments because they increase machine uptime and reduce production run interruptions. According to reports from early users such as Intel, the High-NA tool is already providing twice as much uptime as earlier EUV systems. For top chip manufacturers, this gain in reliability makes the $400 million investment far more economically justified because it lowers operating expenses and boosts each machine's effective output. 4. Single-exposure lithography makes chip manufacturing easier. The High-NA EUV machine's capacity to streamline the chip production process via single exposure patterning is among its most revolutionary features. Multi-turning, which involves a series of exposures and patterning cycles, was necessary in earlier methods to achieve the needed feature resolution. Chip production became more complicated, time-consuming, and susceptible to defects as a result of this method. However, many of these extra processes are eliminated using High-NA technology. 5. Power of the global supply chain and infrastructure. The High-NA platform. The High-NA EUV machine's construction and deployment represent a significant engineering and logistical achievement encompassing an international supply chain. Approximately $400 million is spent on each unit, which needs thousands of separate parts from suppliers in the US, Germany, the Netherlands, and other nations. Because the machine weighs close to 180 tons and needs to be disassembled into hundreds of containers for transportation, it must be delivered to customer fabs using specialized airplanes and ground vehicles. 6. Signals of industry adoption. Long-term effects. The desire of leading semiconductor companies to implement the technology demonstrates the importance of ASML's High-NA machine. With plans to integrate it into its 18A process node and aim for mass production by 2025-2026, Intel was the first company to get a production-level High-NA EUV tool at its Oregon facility. Although their rollouts might be a little behind Intel's schedule, two of the biggest contract chipmakers in the world, TSMC and Samsung, are also getting ready to use High-NA tools for their next sub-2 nanometers and possibly 1 nanometer nodes. 7. Prospects for the future. Automation, AI optimization, and Hyper-NA. ASML's High-NA platform is a foundation for even more ambitious advancements in the future. In order to produce sub-7 nanometers features with even higher throughput, the business is already investigating the creation of Hyper-NA systems with numerical apertures close to 0.75. In order to improve patterning accuracy in real time, anticipate possible faults, and optimize maintenance schedules, ASML is also integrating machine learning and AI-driven analytics into its systems. Let us know in the comments what you think about how ASML makes chips faster with its new $400 million High-NA machine, and don't forget to like, subscribe, and stay tuned for more captivating content on our YouTube channel.